Hi everyone, welcome to my final project presentation for CSCI E-88C. Monitoring the state of the ground and structural health of underground construction projects is mandatory, both from a worker safety perspective, an environmental protection perspective, and the contractual obligation for an asset. The labor-intensive task of site engineers manually taking readings from instruments located all over vast spaces and access-limited site geometries is a prime candidate for automation given the rise in popularity of big data and the advancement of streaming technologies. My final project is centered around implementing a data streaming pipeline which should have the ability to ingest data from a variety of monitoring instrument sources and feed processed data into both batch and real-time analytics platforms, both of which are critical in billion-dollar construction projects. My pipeline is based on the Kappa architecture by J. Krebs. At a high-level overview, raw data is ingested into a Kafka broker, which acts as a messaging service for both producers and consumers. This Kafka service is supported by a Zookeeper instance. I have chosen to use Spark's Structured Streaming API for my pipeline, as it allows for flexibility to deliver real-time streaming as well as in micro batches. Spark reads data from a Kafka topic for incoming raw data, and once processed, the data is simultaneously written back into a separate outgoing Kafka topic for real-time analytics, as well as a PostgreSQL database for batch analytics. Using the Kafka broker as a data source, my real-time views layer is implemented using the ELK stack, which consists of Logstash, Elasticsearch, and Kibana. My batch views layer is implemented using the Python web framework Django, which reads from the PostgreSQL database and serves data to the front-end JavaScript visualization library FlexMonster. As you can see, my structured streaming job has been submitted to Spark and is up and running. Next, I run a script which activates my Kafka producer, and I check that the correct list of topics has been created in Kafka. The remaining 5 panels show the output from Spark into each of the 5 output topics in Kafka, streaming in real time. There's one panel for each instrument type. Now I check that my PostgreSQL database is being filled out with all the data by querying the first 5 rows from each instrument type. This is my Kibana dashboard, which has 5 charts corresponding to the 5 index patterns from Elasticsearch based on the output Kafka topics. As you can see, the data is updating in real time. The red lines represent trigger levels, which indicates where instrument readings have exceeded their limits. An engineer or analyst is able to mouse over each point to determine which instrument produced that reading. This next window shows my batch analytics view. I need to refresh it in order to pull new data from the PostgreSQL database. The individual readings for an instrument over time can be seen by filtering out the other instruments. In terms of scaling to the cloud, I have chosen to use Azure's Synapse Analytics platform to scale my pipeline. Synapse does most of the heavy lifting in pulling in the external API data and storing the raw data. Synapse is also able to run Spark jobs, which made it a simple process for me to deploy my Scala application. It also has a simple integration interface with Azure SQL Database and Power BI for both real-time and batch visualizations. These are 2 screenshots showing the pipeline being triggered at scheduled intervals and the corresponding real-time update of the visualizations in Power BI. The pipeline YAML file is included in my GitHub repo if you would like to have a look at the structure of my pipeline for your own stream processing application. This concludes my presentation. Thank you for listening, and I'd be happy to take any questions.